Hey everybody, my name is Taylor Sparks. We're back with another paper. Now, you've probably used ChatGPT. Nowadays, they're absolutely everywhere, but you might have been disappointed with their performance. They hallucinate, they don't know how to do tasks very specific to material science. It's a bit of a bummer. Well, today I've got a paper that's going to try and address some of that. It's going to try and improve their performance and do it specifically in the realm of material science. This is ChatGPT Material Explorer, and this comes to us from Kamal Choudhary, who recently moved from NIST, and he's now an assistant professor in the mechanical engineering department at Johns Hopkins University, and a friend of ours. What can we say about this paper? Well, first off, he points out that material science lacks dedicated, accessible, GPT-paced assistant tailored to its unique challenges. He says what he's going to try and do here is take all the things that we know and love about large language models and add to them some of the specific things that we need them to do for material science, or the tools that are relevant to material science. For example, crystal graph neural networks, or how to use domain-specific APIs to access material science domain databases, right? He's going to lay out 4 core functionalities in this paper. First, he wants it to be able to intelligently explore these materials and molecular databases, which obviously a domain expert can do, but you have to know the API language, and it's a pain in the butt. 2, he wants to be able to use graph neural network models to predict properties of materials, something that they cannot natively do. 3, he wants to efficiently search archive for papers. And 4, obviously, he wants help with technical writing. Now, if you're not familiar with ChatGPT's custom GPTs, it's actually possible to build custom variations of the GPTs that we know and love, right? Here's an example what that create interface screen looks like, where he was able to develop and create this custom AI assistant. You can find it right now in the ChatGPT store. If you come over here to ChatGPT and you go over to GPTs, and you select this, you can type in and search for all sorts of things. I was just here, so if I type in Material Explorer, right, and I hit enter, sure enough, the very first thing that pops up is this one right here, where it's Material Science Assistant for Materials Data and Simulations, and the author is Kamal. And when you pop that open, this is now going to allow you to learn more about it, see what it's used for. It gives you examples of conversation starters. So let's jump into this and take a look at it. Again, you can do some pretty amazing things with this, right? Look up the SMILES notation for ibuprofen, right? That's pretty awesome. Here it's going to do that. First it says, well, in order for me to do that, I'm gonna have to talk to an external database. And how great that you as a user don't have to mess with this. You can just say, great, you do it, ChatGPT, and it's able to find it and pull up the SMILES string for that molecule, right? And that's just one example of the things that it can do. One of the real strengths of this tool is that he's specifically giving it access to the databases where we know that it contains the information that's relevant to the query. So what types of databases are we talking about? Well, it's all sorts of them. You just saw in the previous second ago that it was able to reach out to NIH Cactus, but there's also the Jarvis DFT database, Materials Project, AFlow, OQMD, Alexandria, and I have personally used all of these, but it requires you to know how to use the API for each specific one. And half the time when I'm doing that, I can't remember exactly how to do it. So I'm going to a language model anyways to get the snippet of code to figure out how to do that. And in a little bit of back and forth with Python, I'm able to do it. So here what he's allowing you to do is use a language model to get the API automatic behind the scenes. You don't have to worry about it. You just provide in human language the query that you're after, like find all materials with silicon and carbon, and voila, it's able to do it. He's got some examples here, right? Finding silicon carbon in the Jarvis database, boom, it's able to do it. And it returns it in a table that you can download, right? Same thing over here. Find materials with carbon and silicon, this time in the Alexandria database, boom, in a table that you can download. Pretty awesome. Another thing that we've been asking our language models to do for a very long time is provide expert answers to sort of question and answer queries. He has a bunch of different examples here. He's got 8 different examples, and he's comparing different models, GPT-4o, ChemCrow, and his ChatGPT Material Explorer. The cells highlighted in green show what he considers an accurate or a reasonably accurate response. And you can see that in some cases, like getting the SMILES strings, it does an okay job on all of those. Here's get me the molecular formula for aspirin, good job. Look up the SMILES string for ibuprofen, good job. But check this out. Find materials having some specific chemical formula in the Jarvis database. ChemCrow and ChatGPT cannot do this, but Material Explorer can because it's been given additional resources that these other ones don't have. How about this one? Predict the properties of this POSCAR using Align. So POSCAR, if you've ever opened up a Civ card, it's basically like what you see here. It's essentially like crystal information. Where are the atoms located? Which atoms? What's the unit cell? Information like that. Again, ChatGPT is like, well, I know what Align is, but I don't know how to use it. I can't use it. I could give you a Python script and you could try it, right? But this one is actually able to do it. ChemCrow also is not able to do it. Here's another one. Find me papers with magnesium boride on archive. Don't get the right work with the other one too, but you're able to find great results with Material Explorer. How do I interpret a phase diagram? They can all help with it. Explain the band structure of silicon. They can all do it. So I think this is really cool. Kamal has done something pretty impressive here, and it's just version 1.0. I can't wait to see what he does in next iterations. But for now, I hope you'll check out all of this in the latest edition of IMMI.